Alright, today we are graphing things in vertex form. You notice the h and k and a, just like we had in absolute value and in general transformations, all those same rules apply. So your k is going to make your graph, your parabola, shift up or down. It'll go up if it's positive, down if it's negative. The h is going to move it to the right, shift your parabola right or left. Again, opposite of intuition. So if it's a x minus, it's going to go right. If it's an x plus something, it's going to go to the left. The A is your stretch or shrink, a vertical stretch or shrink. That's going to make your parabola appear wider or narrower, although we just know that it makes it taller and shorter. It'll be a stretch if A is greater than 1, be a shrink if A is between 0 and 1. If there's a negative out front, that's going to reflect your parabola over the x-axis. Some things we need to talk about is your parent function. When we do the stretch and shrink, because it doesn't have a parabola doesn't have a defined slope, we're going to have to do our stretch and shrink a little bit differently by hand. So if you think about your normal parabola, your parent function that looks like this, from your vertex, which is that bottom point, so this will be from vertex. So from your vertex, normally you would go right 1 unit, and your graph would go up 1 unit, because if you're thinking about it, this would be normal. Sorry, you can't read any of this. This right here says from vertex. This right here says normal. So typically from your vertex, you go right 1 unit, up 1 unit, because 1 squared is 1. Normally from your vertex, if you go right 2 units, you'd go up 4 units. Okay, and again, since we're still dealing with y equals x squared as our parent function, if we were to go right 3 units from our vertex, 1, 2, 3, we would go up 9 units, which of course I can't actually fit on here. And keep in mind your parabolas are symmetrical, so down the middle of your parabola through the vertex, it's symmetrical. So all these points you're going to be able to just reflect across that line of symmetry. So you go left 1, up 1, left 2, up 4, left 3, up 9 to make the other side of your parabola. And that's how you're going to graph the parabola correctly. If you have an a value, so if your a is equal to anything other than 1, then you would multiply the up value. So if we do a little example down over here, if we have y is equal to x minus 3 squared, we're going to go ahead and graph that. So if you notice inside my parentheses, that's a minus, so that would tell me to go right 3 units. There's nothing on the outside, so it's only going to go right 3. There's no a value, so we're just going to go with the normal flip. So if we go right 3 units, that's where my vertex is going to be. So we always need to label our vertex. So our vertex is going to be 3, 0. And looking back up here at your vertex form, the vertex is always going to be at h, k. So you'll always plot your vertex first. The axis of symmetry, like we said, that's the line that goes through the vertex. It cuts your parabola in half. So the axis of symmetry, because it always goes through your vertex, it's a vertical line. It'll be x equals h. So whatever that x value is of your vertex, that's where your axis of symmetry is. So here's my vertex point at 3, 0. Since there's no stretch or shrink, it's just going to follow the normal pattern. So from my vertex, we'll go right 1 unit, up 1, because 1 squared is 1. From my vertex, we go right 2 units, and then we'll go up 4, because 2 squared is 4, and we don't have an a value. And then we can just reflect those points there. Let's go ahead and put in 3, 9. So from my vertex, we go right 3, up 9. So we can draw a beautiful graph. There is our parabola. And we know that the axis of symmetry is what cuts it in half. So the axis of symmetry goes right through the middle. So that means our axis of symmetry is the line x equals 3. Okay, so now let's look at a second example. So here we have the equation y equals 2 times x minus 3 squared minus 5. So we're going to go ahead and start and say our vertex is at the point positive 3, negative 5. You use the opposite sign there. This goes right 3, down 5, and then, oops, that's a v, not a 5, down 5. And then we're going to vertically stretch it by a factor of 2. Okay, so we always plot our vertex first. We know if our vertex is 3, -5, then the axis of symmetry will be x equals 3. So 1, 2, 3, -5. Here's my vertex. Okay, now we're going to look at my stretch and shrink factor to know where to put my other points. So normal, so this is my right. So normally if I go right 1, normal would be up 1. But since it's a vertical stretch of 2, we're going to multiply the normal up by 2. So this is times up. So now it's going to go up 2. Normally we would go right 2 up 4, because 2 squared is 4, but now we have to multiply that up value by 2, so we're going to go up 8 instead. Normally it would be right 3 up 9, because 3 squared is 9, but now since that a value is 2, we're going to multiply the up value by 2, so we will go up 18 instead, which is not going to fit on our graph, but just that way we know. So from my vertex, I'm going to go right 1 up 2, because, oops, that was 1, because that shows my stretch factor. From my vertex, we'll go right 2. Now we're going to go up 8 because we multiplied it by 2, so that'll be up here at 3. And if we go right 3 up 18, that's not going to be on my graph. So let's just reflect our points. So we'll go left 1 up 2 and left 2 up 8. And there's my parabola. Okay, here's my vertex down at the bottom, and we told ourselves the vertical, the axis of symmetry is that vertical line through the vertex, which is x equals 3. The last thing we're going to look at is our graphs in intercept form. So here you notice you have the two different sets of parentheses. This is going to show us where our x-intercepts are, or our roots. That's why it uses as an r, because those are called our roots as well. We still have the stretch and shrink factor. Here are our roots, which are x-intercepts. And you're always going to use opposite sign. Use the opposite sign of what's there. Okay, so that's going to tell us where we cross the x-axis. In order to find my vertex, we need to find the middle of those roots. So wherever they cross the x-axis, the axis of symmetry of the vertex is going to be exactly in between those two things. So to find my vertex point, it's going to be r1 plus r2 divided by 2. That'll tell me the x value because that's the average of those 2 points. It's in between those 2 points. The y value, you're going to take that x value and you're going to plug it into your equation. So f of r1 plus r2 over 2. So what this means is this is your x value. Then you're going to plug in x to find y. So if we have the equation, we're going to use the equation y equals 2x minus 3 x plus 1. So we know looking at this, my roots, so I've got one root at positive 3, one root at negative 1. So we can go ahead and plot those. So we've got a root or an x-intercept here at positive 3, another one at negative 1. Now we need to find my vertex. So my vertex, we need to take the average of those numbers. So 3 plus negative 1 over 2. This is going to help me find my x value. So 3 plus negative 1 is 2. 2 divided by 2 is 1. To get the y value, we need to plug that in. So we're going to plug in f of 1, plug that into my equation. So we've got y equals 2, 1 minus 3 times 1 plus 1, which is 2. 1 minus 3 is negative 2. 1 plus 1 is 2. So 2 times negative 2 is negative 4 times 2 is negative 8. So my vertex is at 1, negative 8. And if you can see now, we have enough points to plot our parabola. Or draw on our parabola. It's going through those x-intercepts. So my vertex is at 1, negative 8. My axis of symmetry is going to be x equals 1, because that goes directly through my vertex. So in intercept form, you plot your x-intercepts, use the opposite signs, find the average, or you can just look at your graph and know where the middle is, and then you're going to plug that x value into your original equation in order to find the y value of your vertex so you can finish drawing your graph.